Hello, this is Mrs. Scarpel, and I am going to take you through graphing from factored form. When we're graphing from factored form, there are some steps we need to take, some pieces of information we need to take before we do that factoring. And one of the first things we need to do is we need to make sure that we know what our equation is. So I'm going to give you just a general equation for us to work off of as I explain the steps for doing factored form. So if I have an equation in the form y equals a times x minus m times x minus n, I can identify different pieces. My x-intercepts are going to be m and n. So it's going to be m0 because the y value of an x-intercept is 0, and n0. Now notice I did not write negative m and I did not write negative n like you see in this equation. That's because these values of x in our x-intercepts are opposite of what you see in the factors. To find the line of symmetry of the parabola, that's going to be x equals, you add the values of your x-intercepts, so add m to n and divide by 2. That will give you your line of symmetry. To find your vertex, you're going to replace x with the value of the line of symmetry and solve for y. So we've got this equation in factored form. You'll replace the x values in this factored form with the value you get when you find your line of symmetry, and then you'll simplify the expression to get y. And you'll combine the x value with the y value you find to write your vertex. To find the y-intercept of the parabola, you're going to replace x with 0 and solve for y. And the reason we replace x with 0 is because the x value of the y-intercept is 0. To find the vertical stretch, you want to look for a. Here, a has been factored out, so we see that it has a stretch. Just like in our vertex form, we have a there, so it factors out. So let's take a look at our first example. We will do 4 of these. Our first example is x squared minus 2x minus 8. We know that because this is x squared, or we found when we were factoring, because this is a single x squared, I can take the time to look for what multiplies to give me 8 that will add to give me negative 2. So our options are 1 and 8 or 4 and 2. I'm going to try the 4 and 2, and that will work as long as the 4 is negative. And negative 4 times positive 2 does give me the negative 8. So my factored form becomes y equals, or f of x equals, x minus 4 times x plus 2. My x-intercepts are going to be positive 4, 0, and negative 2, 0. My line of symmetry, I'm going to add 4 to the negative 2, my x-intercepts, and divide by 2. So that's going to be 2 divided by 2 is 1. So x equals 1 is my line of symmetry. I'm going to use that 1 to help me find my vertex because the vertex is on the line of symmetry, so it's going to have the same x value. So to find the y value of my vertex, I substitute 1 for x, and I simplify. So we now have negative 3 times 3, which equals negative 9, giving me a vertex of 1, negative 9. The y-intercept, remember I said, is a very similar process, except we replace x with 0. So 0 minus 4 times 0 plus 2 will be negative 4 times positive 2, which is negative 8. So the ordered pair for that y-intercept is 0, negative 8. And when I look at my equation, there's no a value, so there's not going to be any stretch. So then I can place my axes on my graph. Oh, I want to do that in a different color. Identify my axes. Oh, I changed the screen without realizing it. Let me go back here. Here we go. Let's graph this one. And I need to be able to go down 9 for my vertex, so I'm going to place that x-axis just a little bit higher. I'm going to start by plotting my x-intercepts at negative 2, 0, at positive 4, 0. I'm going to draw a dashed line for that line of symmetry through x equals 1. I'm going to plot my vertex on that line of symmetry by going down 9 and plot the y-intercept at 0, negative 8. Its reflection would be at 2, negative 8. And then I am going to draw my parabola. So that's our first one. The second one, we have a negative in front of x squared. So I'm going to rewrite this so that the negative is pulled out, is factored out. You might want to think of it as the distributive property backwards. So to get a negative x squared, I take negative times positive x squared. To get the negative 6x, I would multiply that negative times a positive 6x. And to get the negative 5, I would multiply the negative times a positive 5. My factored form is going to have that negative in front. It doesn't go away. But for the factors themselves, I can focus on what multiplies to give me 5 that will add to give me 6. Well, our only factors for 5 are 1 and 5. And we can verify that 1 plus 5 does add to give us 6. So our factors will be x plus 5 times x plus 1. And from there we can identify the x-intercepts. One of them is at negative 5. The other one is at negative 1. So negative 5, 0, negative 1, 0. The line of symmetry. We're going to add -5 to -1 and divide by 2. So that's -6 divided by 2 is -3. So that line of symmetry is x equals -3. We use that x value in our factored form to find the vertex. So we have y equals -3 plus 5 times -3 plus 1. So that's a -2 times -2 for a y value of on our vertex of 4. So the vertex is at -3, +4. The y-intercept, do like you did for the vertex, except replace x with 0. So we have 0 plus 5 times 0 plus 1. So we're going to have a -5 times 1. 0 plus 5 is 5. And we have the negative from out front. So I could write it with the 5 in parentheses so that you see that negative is what was coming from out front. So -5 times 1 is -5. The y-intercept is 0, -5. And I do not see an a value, so we can say again that there is no stretch. So let's graph this. We have intercepts at -5, 0, -1, 0. We have a line of symmetry at x equals -3. The vertex is on that line of symmetry up 4 units. And the y-intercept is at 0, -5. And we can plot its reflection on the other side of our line of symmetry. And then we can go ahead and graph our parabola. And notice that this parabola is open down, which is what we would want since we have that negative in front of our line of symmetry. In our next example, we do have an a value. We have 2. I do see, though, that 2 does divide 12 and 16 evenly, so to help with our factoring, I'm going to factor out the 2 first. So that's going to be x squared minus 6x plus 8. I divided everything by 2, wrote that 2 in front. And then I can ask myself what's going to multiply to give me 8, that's going to add to give me -6. 2 times 4 does multiply to give me 8. If they're positive, though, they don't equal -6 when added. However, if they're both negative, they do. And -2 times -4 is going to multiply to give us a +8. So the factored form for this is going to be 2 times x minus 2 times x minus 4. So the x-intercepts will be 2, 0, and 4, 0. The line of symmetry will be found by adding 2 and 4 and dividing that by 2. So 6 divided by 2 is 3. So we have a line of symmetry of x equals 3. We use that value of 3 to replace x to solve for the y of the vertex. So that's 3 minus 2 and 3 minus 4. So we have 2 times 1 times -1, which equals -2. So our vertex is 3, -2. For the y-intercept, replace x with 0. So we have 2 times negative 2 times negative 4, which is going to be a positive 16. So a y-intercept at 0, 16. And we have a stretch by a factor of 2. So let's draw our axes. I don't know if I have enough room on my graph for our y-intercept, but I have placed my x-axis as low as I can and still plot my vertex. So 2, 0 and 4, 0 are my x-intercepts. My line of symmetry is at x equals 3, with the vertex being located at the point 3, negative 2. So let's see if we can fit the y-intercept on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It would be approximately up here. But if we'd like to have another point to help us, and we know we have this stretch of 2, we can use those anchor values that we did with our vertex form. So when we moved 1 to the right, 1 squared was 1, but multiplying it by 2 moves it up 2. Going to the right 2 units, 2 squared is 4. 4 times 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And there's its reflection. So now I can graph my parabola, trying to make sure that it's rounded at the bottom and doesn't look like a V. And we have our parabola. And one more. This one has a negative 2, so it has the stretch of 2, but we can't factor out that stretch of 2. The only thing we can factor out is the negative, so I'm going to pull out the negative. So it becomes a positive 2x squared plus 5x minus 3. And then to help with my factoring, I'm going to take 2 times negative 3 is negative 6. So I need 2 factors that will multiply to give me negative 6, that will add to give me 5. Now, I know a lot of students will say, well, 2 and 3. You're correct. 2 plus 3 does equal 5. But if they're both positive, I won't get negative 6. So it cannot be 2 and 3. So make sure you are checking to make sure it works, signs and all. The only other factor pair is 1 and 6. But if they're going to combine to give me a positive 5, then I need to use a negative 1. And then I'm going to use the area model to help me with my factoring. So we know we have 2x squared. We know we have minus 3 units. We need to find the rest of the information. We also know we're going to use a negative x and a positive 6x. So a value that goes into both 2 and 6 is 2. So I'm going to be multiplying 2x with a positive x to get 2x squared. And I'll multiply 2x times a positive 3 to get 6x. Now to get this negative x, I'll take x times negative 1, and then to make sure that it works for our units, negative 1 times positive 3 is negative 3. So our factored form is a negative that we factored out, 2x minus 1 times x plus 3. One of the x-intercepts is going to be negative 3, 0. To find the other x-intercept, I'm going to have to set 2x minus 1 equal to 0 and solve for x. So I'm adding 1. So we have 2x equals 1 and divide by 2. So we have an x-intercept of 1/2 or 0.5. To find the line of symmetry, I'm going to add negative 3 to 0.5 and divide by 2. And negative 3 adding 0.5 is negative 2.5. And when I divide that by 2, I have a value of negative 1.25. I'm going to use that negative 1.25 to help me find my vertex, or the y value of my vertex. So we still have that negative out front. We're going to take 2 times negative 1.25 and subtract 1 and multiply it with negative 1.25, adding 3. So we have negative 2 times negative 1.25, subtract 1 is a value of negative 3.5. And negative 1.25, adding 3, is a value of 1.75. So a negative times a negative becomes a positive. 1.75 times 3.5 is 5.25. So we have a vertex of negative 1.25, 5.25. The y-intercept, again, put 0 in for x, so we have a negative, and then we have 0. Actually, let's start this over. We have the negative. Then we have 2 times 0, subtract 1, times 0 plus 3. For a negative, 2 times 0 is 0, subtract 1. Zero plus 3 is 3, so a negative 1 is a positive 1 times 3 is 3. So we have a y-intercept of 0, 3. And we did have this a value of 2, so we have a stretch by a factor of 2. So let's graph this. Drawing my axes and looking at my numbers. Vertex, I think I'm going to have to go with being able to just estimate my values. So we know we have an x-intercept at negative 3. We know we have an x-intercept at 1/2. The line of symmetry is going to be at negative 1.25. the vertex is going to be at negative 1.25, 5.25, the y-intercept is at 0, 3. So that's 1.25, so we want to go about 1.25 the other way. And then we can graph our parabola. And we have covered every possibility for what we might need to do when we factor. We have covered finding x-intercepts to the line of symmetry, to the vertex, to the y-intercept, and the stretch, so that we can see what happens with our graph. And this concludes the video on graphing from factored form.